All right, let's look at collecting like terms. This could be a review as well. The whole chapter 1 is kind of a review of Algebra 1 and pre-algebra. So once we get over this, then we really get into the bigger, heavier stuff. All right, so collecting like terms. Now, like terms are terms that have the same variable. Remember, the variables are the letters, and sometimes you can have multiple letters. Now, the number in front of the variable is called the coefficient. So that's a term, if you're not familiar with, you want to have mastered the coefficient. Now, simplify the following examples by adding or subtracting the like terms. All right, so the first thing you want to do is be able to identify the like terms. So for number 1, we have 7x and 8x. Now notice I circled the plus sign. It's very important that you identify the sign. Most students, when they have a mistake, it's because they forget the sign. And that really comes into play when you're dealing with subtraction or the negative signs. Now that I've identified those, I can add them. You can think of it as 7 xylophones plus 8 xylophones. And if I add those together, how many xylophones would I have? So 7x plus 8x is what I would do there. And then I want to add the other two like terms, which is the 3y plus the 4y. And you could think of that as 3 yellow bananas plus 4 yellow bananas, right? So you're going to add them up and get an actual value. So 7x plus 8x is 15x, or 15 xylophones if that helps. And 3y plus 4y is going to give you 7y. All right, so that would be your final answer. That is the answer. There's nothing else you can do. You have collected or combined the like terms together. All right, let's try number 2. Once again, you can pause the video, see if you could do it and get the correct answer before playing it and seeing what that value is. Okay, so this is where I'm going to do the distributive property that I spoke of before. Remember, the distributive property says that whatever is on the outside of the quantity is multiplied into each term. So that means 4 times x. Remember, it's multiplication because that number is outside the parentheses. And also 4 times the 2. 4 times x is going to give us 4x, and 4 times 2 gives us 8. Now we do the same thing with the second part of the expression, since it's outside of a quantity as well. But we have to be very careful. There's a negative in front of that 2. And so that actually belongs to the 2, and we're going to multiply negative 2 inside to the x. And then what we do there, we do the same for that last term, because every term inside the quantity must be multiplied. One of the most common mistakes is to forget to multiply all the terms. So negative 2 times x will give us negative 2x, and then two negatives make a positive. So negative 2 times negative 3 will give us positive 6. Now that we've done that, it looks like number 1, pretty similar. And so we can now collect the like terms. And so our like terms here are 4x and negative 2x. And so if we put those together, we can subtract them. And then we have two numbers, two constants. They are terms as well. And so we can add those two terms together, which is 8 plus 6. Now that we know what our like terms are, we've put them together to make it easier. 4x subtract 2x will give us 2x, and 8 plus 6 gives us 14. And that's our answer, 2x plus 14. Okay, so example 6 is math muddles. So what we want to do here is create a muddle, and then we're going to see if we can simplify it using all the techniques we just learned. So you want to buy either a flashlight or a headlamp as a gift for 12 people. Now flashlights cost $24 each, and headlamps cost $21 each. Write an expression for the total amount you will spend. Then evaluate the expression when 6 of the people get flashlights. Alright, so first thing you want to do is identify different aspects of this question. So we can use the same model that we had before. Create a verbal model for the total cost. Sometimes it helps to write what you're finding so you know at the very end. Write out the expression. That means label the different aspects of your model with the variables or numbers. And then finally you substitute the values that you need in there. And you can see it says that at the last sentence. Evaluate the expression when 6 people get flashlights. Alright, so let's go ahead and start this one. The first thing we want to do is come up with the verbal model. And so you want to kind of visualize what you're doing here. You're finding you got two different things that you're going to be adding, flashlight and headlamp. The price of the flashlights, right, plus the price of the headlamps. And so you need to know, well, how many flashlights I'm getting. So if I get two flashlights, that would be $48, right? 2 times 24. So that means my first part of my model must be price of the flashlight times the number of flashlights. And then I'm going to add that to the price of the headlamp times the number of headlamps. Once you're going to get a verbal model, it makes it easy now to come up with the algebraic expression because now you can assign variables. So for flashlight, you can use any variable of your choice. Let's just use n again. So 24n, because the price of the flashlight is $24. I don't know how many flashlights I will have, so I just use an expression. So when I come up with how many I have, I just substitute it in there. Plus the price of the headlamp, which is 21 times n. 12 subtract n. And the reason why we're saying 12 subtract n is because there are 12 people in all. And since I chose the flashlight to be n, then how many people are left? Well, let's say I chose 8 people to get flashlights. Then how many people can get headlamps? Well, there's only 4 people. And so we know that it's 4 because 12 subtract 8 is 4. And no matter what combination I use, if I say 2 people get flashlights, then how many people will have headlamps? Then I'll say 12 subtract 2 is 10. So it's 12 subtract whatever the amount of flashlights are. And so since I can see that model, then what I simply do is rewrite that as 12 subtract n. Now that concept appears very often in algebra. So always keep it in your mindset that if I have a total of something and it's split up into 2 or 3 different things, then I can create another expression to represent the other item. And so whichever one I choose first, if I choose flashlights first, I assign it a variable, and then the second item, when I assign it a variable, it's the same variable subtracted from the total that the two add up to be. All right, so that's my expression, 24n plus 21 times the quantity 12 subtract n. So now that I have my expression, there's one last step. The question next is then evaluate the expression when 6 of the people get flashlights. So if I know how many people are getting flashlights, I can substitute in there. And that means I have 24 times 6 plus 21 times the quantity, 12 subtract 6. And because 12 subtract 6 will give you 4, then you can see exactly 12 subtract 6 will give us 6, sorry. Then you can see that those two items add up to be 12. All right, so now we can simplify, use your order of operations. Start with your parentheses, so 12 subtract 6 gives you 6. 24 times 6 gives you 144. Now, when you put the equal sign and then another term, we actually call that an equivalent identity. It's equivalent to another expression. And so it is not saying, sometimes it confuses students, but it's just showing a progression of how we are simplifying the expressions to an equivalent expression. And a lot of times we call that the identity. All right, so we have 144 plus 21 times 6. Multiplication is stronger than addition, so multiply 21 times 6, which is 126. And then when you add those two together, you would get 270.